Okay. Okay. Good morning. Good morning. Good morning. Good morning. Wait, good morning.
Morning.
Good morning. Aha, that's how that works. Okay. Good morning. Good morning. Good morning. Okay. We're all good morning. Aha. They was right. Aha. Okay. Oh, double, triple.
It
Oh,
worked.
it totally works. You're the hero. Oh my God, that's amazing. Okay. Thank you. Okay. Now that's like I'm opening up a portal just for that. Thank you, Lunar. That's great. Um, oh my God, that's like life-changing. Okay. Okay, and we won't do that the whole class. All right. Anyway, good morning, everybody. Thank you, Lunar, for that. And good morning, Mohammed. I'm going to look at the chat right now. Oh my God, that's like totally okay. That is life changing. Um, good morning, Jalila. Good morning, Melanie. Oh, and there's Mohammed. All right. Oh my God, that's amazing. I mean, is it amazing? It is kind of amazing. All right. And apparently, and okay, well, I'll keep saying good morning, but I appreciate it, particularly you two and anybody else on this morning, because this is so crazy that we're on Zoom again. Believe me, I know. I will talk about that for 2 seconds, in 2 seconds. Um, so yes, good morning, Jalila. Good morning, Melanie. Good morning, Luke. Good morning, Josh. Good morning, Michelle. Good morning, Mohammed. I'm in a chair. It's great. Uh, that's actually a line from a movie. And I'm in. Oh no, it's from the Blues. I'm in a truck. It's in the Blues Brothers. If you've ever seen. Anyway, all right. And good morning, Nadine. Okay. Good morning. Anybody else that I didn't say? I'm looking at the. Good morning. Oh, Jalila for the double. Thank you. Okay, so guys, and I will switch the view, but I'm having too much fun with this for the second. But I believe me. I mean, some of you know I travel a long way to get to our classes on Monday. But so this guy, but I'm totally bummed to have not traveled this week. Believe me, you all did the thing of signing up for a full in-person class. I love seeing you all in person. I love seeing you in your lab. I can't believe that we're missing another Monday. Believe me, I'm not going to spend the 4 hours talking about it, but my heart goes out. I know, of course, it's a break and all that, but like this does not help any of us. So anything you can do to stay alive and stay engaged in this double Zoom will be greatly appreciated. I mean, again, that's why this funny view, if it helps at all for 5 minutes, that's great. I will switch the view if it makes it easier to see stuff. But the other thing is, of course, right. Oh, and so right now we do have to make tracks with the material. Like we haven't seen each other for so long. So I am gonna try. I'm gonna ask you again for this double period. First of all, when you need to take a break, just take the break. Like I'm not gonna take a break. I'm just gonna go. I mean, if we can let out early, we will, but we might not because whatever. We just because there's like a lot and things don't go as quickly on you don't cover material as quickly on Zoom as in life. So in a second, I'm just going to get going. I'm going to ask you though. My fight is going to be for me not to rabbit hole. Like I want to speak more linearly and just go forward with the material, but that is not to rush you. That is to rush me. So I'm going to ask you even more than usual. Bear with me if I go through ideas maybe more quickly than usual, but you stop me. Please, all of you, use the direct chat at any time, either to say move faster or to say move slower or say that again, or even just to say in the direct chat, like I spaced out for a minute or the cat like jumped on my lap. Like I didn't quite understand. I have a feeling you just said something important and I didn't quite get it. Like anything, okay? Because once I get going in a second, because right now we're sort of behind by not we're not behind the material, but like we're behind the other sections for what because of these holidays. And I know it all catches up, but so I want to catch you up. Um, um, so I want to catch you up in a second, and I will. But the other quick question I'm afraid to ask this. Oh wait, there's something in the chat. Hold on. So we're gonna get going in a second. Yeah. Wait, what? Oh wait. Oh, sorry. I'm sorry. Oh my God, that's scary. Okay, I'm sorry. You're the Right. You're okay. You're not as behind. I'm sorry. It's the other. Quite right. Thank you. Actually, I was just about to. You're right. Oh, so I'm actually looking at the wrong board. Thank you. I'm totally thinking of the other class. You're not actually behind. I'm sorry. I shouldn't say behind. You're totally okay. Actually, you're. I'm not as worried about you. Thank you. I'm totally looking at the wrong. Thank you. Okay, actually, you're not the issue as much. All right, still everything and you don't have to sit for a double period. Great. Actually, yes, I was completely wrong. So this is your board. I'm looking at the correct board for you now. Okay. Thank you. But then just one quick thing I will ask, maybe for the sake, somewhere in here, there's got to be a day where like Friday is Monday or Thursday is Monday or something. If anybody knows offhand and you can tell me in the chat, that would be great. So I could start planning for it because I'd like to see you in person again. So if I have whatever, if you know, if you don't worry about it. But right, we have a single period. Right. Okay. Um, so then I'm gonna get to the material. I want we're gonna try to I want to get back to this right to the cross product business, the math that we were doing last, um, the math that we were doing last Wednesday. Yeah. So the quick, and I want to technically, as of the end of last Wednesday, technically, I gave you everything you needed to know to finish the math methods homework, the homework two, and turn it in by this morning, which I think you did. Oh, Thursday. There's a Thursday schedule on Tuesday, April 20th. Okay, thank you. I see that single chat. I mean, the direct chat. That's super helpful. There's a Thursday schedule on Tuesday. So that, okay, but when does that make up the money? Okay, thank you. And you should submit for points for that, direct app person. Okay, I, all right, summary of where we were last time. Okay, the summary of last time is that if you have two vectors and you're doing the cross product between the two vectors, then you are measuring the extent to which the two vectors are perpendicular with each other. The result is a vector. The magnitude of that resulting vector is the magnitude of one vector times the magnitude of the other vector times the sine of the angle between them. And the direction of that resulting vector is the positive direction of that resulting vector is assigned by the convention known as the right-hand rule, right? So what we're saying is if you have two vectors A and B, no matter what angle is between them, no matter how much they differ in direction, they lie in some plane. There is a plane that contains both of those vectors, no matter where they are. So to get the direction of the vector that results from crossing those two vectors, you take your right hand, you place the fingers of your right hand along the first vector, that like the vector that's written first in the multiplication process. So if we're doing A cross B, you literally take your fingers and place them along A. You place them in a manner that would allow you to naturally curl them toward B. And wherever your thumb is pointing, that's the direction of the answer, right? So what we're really and again, this is a summary of what we did last Wednesday, and in principle, you needed this in order to complete the homework or was helpful to complete the homework for today, but like you did get it and you did complete the homework today, and I'll get it back to you soon. Um, but I'm saying it now. I know the homework's already in, but number one, if you want to make corrections later for more points, this might be helpful. But number two, I'm using this because I want to move forward with this idea to a place that was not in the homework, just to warn you. Like, I want to do something further with this idea that we need later in the course, like in a moment. So I'm just making sure we're clear that you place your fingers on A, you curl them toward B, your thumb is the direction of the answer. So in this case, like the answer would point into the plane of the blackboard as opposed to out of the plane. And the way you would designate into the plane is you would draw an X as though you were looking at the back of tail feathers emanating away from you in some medieval arrow that represented that vector, right? And if something were coming toward your face, you would just see the tip of the arrow, so we would draw a dot. What I'm trying to review right now, I'm trying to say cross product cares about direction. So it measures how much the direction of two vectors makes a difference, like how much they differ, as opposed to the dot product, which looks at how much the directions don't differ. A dot product looks at how much two vectors are lined up with each other. The cross product looks at how much they are directionally affecting each other. The answer, therefore, is perpendicular to both vectors. So the answer has to be either going into the plane or coming out of the plane of the two vectors. Like that, you would know, if you understand this concept, you would predict that even without the right-hand rule. So then the only question that would be left to you is the answer out of the plane or into the plane? Whatever the answer is, the opposite of that direction would be negative. So it's really all a big question of like, what direction are we assigning positive? And so we adopt this convention. And the convention is, okay, do this thing with your right hand, which is just taking advantage of human anatomy just to force a particular direction along the remaining axis. Okay, so in this case, the answer to the cross product would be into the plane. I want to reinforce with the cross product. If you're following, so really, again, if you're following what I'm saying, you'll realize that the right-hand rule is just making a positive negative decision for you, but it's ensuring that your positive negative decision is the same as everybody else's. Like even if you're a lefty, like you're using your right hand just to do the same thing as everybody else. And the whole, yeah, okay, so that, but notice if you follow what I'm saying, you will notice that this operation is what's known as, it's not commutative. The order does matter. It's technically known as anti-commutative because if you switch the order of the operation, you will definitely get the negative of your original answer. Like B cross A gives you the opposite answer from A cross B. And in the right-hand rule, something like everything else, you want to practice it on your own. Like it sounds obvious when I say it, but there's like a lot of ways to do it wrong until you get used to it. So if you were doing B cross A, you'd place your fingers along B and curl them up to A, and you notice that your thumb points the other way. If you don't like this curling business, and some people don't, the other way you can do it is you can just say, like, you can say, how do I see? I never do this. Like, if you don't like the curling business, the whole idea is to get three perpendicular axes. So basically what we're saying is if you just hold your right hand naturally, if you hold your right hand naturally and like make a gun with your thumb and forefinger and then stick out your second finger in the only natural way that it can, you will automatically have three axes that are perpendicular to each other in the correct way. So for some people that like makes a lot more sense, fair enough. So sure, like if you like that better, stick your first finger along A. See, now I'm going to do it wrong though. Yeah, and your second finger along B, and your thumb will be the answer. Okay. You'll know you're doing it right. Just if it's on, you'll know you're doing it right if you're not doing something unnatural or weird or particularly weird or painful with your hand. and you'll know you're doing it right. Oh, there's something in the chat. And I'll switch the view in a second if that's really annoying people. And you'll really know you're doing it right if when you switch the order, if you cross B into A, you should get the opposite answer. Then you know you're doing it right. Okay, wait, chat, hold on. I'm sorry. Okay. So X is away from me into the plane. So correct. Okay, so X is away from you into the plane. Oh, so when I draw an X, I mean away from your eyes into the plane. That's right. It's like an arrow going away from your eyes into the plane of the blackboard or the piece of paper or whatever. And the opposite of that coming into your eyes would be a dot. Look, would be like this. So let me so this means into the plane, like away from your eyes, and this would mean out of plane. So we draw a circle just to say like focus on whatever's inside this circle. And if there's an X inside the circle, it means the back of an arrow. And if there's a dot inside the circle, it means the front of an arrow. If that makes sense. That was a great question. Okay, yes, great. Okay. And I'm going to switch. All right, so that's the cross product. And again, it requires that we now like look into three dimensions of space. Okay. And for what it's worth, I'm going to talk more now about the cross product and the dot product. So I'm now going to shift the page. I'm going to say more about this. The stuff that I'm going to say now, you did not need for the math homework. Like it won't, and you don't need it to correct math homework, but you're really going to need it for a little bit later in the course, specifically when we get into magnetism. Okay, just so that you know, and also just for life, if you ever do any more with math, like vector calculus, like Calc 3 or anything like that, you'll really need this. But so, and you really need it for physics, for all of physics. But I want to talk about something now called unit vectors. And I don't know, let's see. Tell me in the private chat, actually. Tell me in the, oh no, don't tell me in the private. Okay, so I'm going to talk about unit vectors. Why am I going to talk about unit vectors? I want you to notice that even on this back page, when I said like, okay, the magnitude of the cross product is AB sine theta, and then when I got into the direction of C, all of a sudden I got into all this English. Like to talk about the direction of a vector by itself, I suddenly was forced to use all this English. A vector is a quantity that has magnitude and direction, but it seems like we have a very vague way of and a very kind of weird way of talking about the direction of a vector. It seems very inconvenient. There's a way of focusing in on the direction of a vector that's just as mathematical and precise as the way that we focus in on the magnitude of a vector. And that's what I want to show you right now. Okay, we're going to define, oh, and now this is a good opportunity for me to change the view of the screen because I can see it's going to start getting blocked. All right, maybe tell me in the private chat later whether this view like helps people or not even just focus or whatever, or if it helps with the recording or not. You can tell me later, but I'm going to leave it now because I can see I'm going to start getting blocking the board. Okay, um, 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 okay, I'm going to define something called a hat. That A with a caret over it from now on is called a hat. Like the caret is called a hat in physics. A hat from now on for any vector A is defined to be the vector A divided by its own length, A. Like a vector divided by its pure magnitude gives you this thing called A hat. And from now on, so I'm going to write it again on the next board. From now on, you read it out loud as A hat, but what it means is the unit vector for A. Now, what is that? It's literally the vector A divided by its own magnitude. So, for example, if you had a vector of 3 miles pointing to the northeast, then according to this rule, you would take 3 miles pointing to the northeast and you would divide it by 3. So you would get 1 mile pointing to the northeast. What's the point of that? Well, the point that 1 mile pointing to the northeast would now be the unit vector for that measurement. And the purpose of is it is a vector that just points in the direction that we're talking about, but doesn't have any particular size. It has a size that doesn't change numbers when you multiply by it. Um, so so it's a unit vector. It's a vector of unit length pointing in a particular direction. What's the point of that? Well, it allows us to rethink the vector in the first place. If you look at the bottom line of this, the purpose of the unit vector, if you define, oh, so I should say the unit vector is a vector. Like it has direction and it has magnitude. It's just that by definition, its magnitude is always 1. So the purpose of it is this line here at the bottom. The purpose of it is that from now on, we can think of that vector that's 3 miles to the northeast. We can think of it, first of all, as having two pieces, a direction piece and a magnitude piece. And instead of thinking them as like loosely tied together in a sentence of English, we can think of them as packaged together in literally a monomial, like in a mathematical object. We can think from now on that a vector is a pure size, A, multiplied by a pure direction, A hat. Put one last way, we can say from now on, the way we can, if you're thinking of a vector that's 3 miles, like a displacement vector that's 3 miles pointing to the northeast, you back up and you actually think of it as having been constructed in the following manner. We think to ourselves, we build it piece by piece, the direction piece first and the magnitude piece second in our minds. Like, so we think, imagine a 1 mile vector that's pointing to the northeast. So we get that direction fixed in our mind, like go northeast. And we think of a 1 mile, an arrow pointing to the northeast that has a length of 1. Then we multiply that unit vector by the number 3. In other words, we take that unit arrow and we stretch it out by a factor of 3. So from here on in, when we think of vectors, we think of vectors as a scalar multiplying a unit vector. And in fact, that's why the raw number is called a scalar, because we think we have these little unit blocks, these little unit vectors that we then stretch or shrink accordingly to make them the proper size. Okay, so I'm saying two things. I'm going to move on. I'm really saying three things. I'm saying there's now this concept called a unit vector. It's a vector with a particular length. It's a vector with a particular direction that always, by definition, has a length of 1. And so that's the first thing I'm saying. The second thing I'm saying is then notationally, from now on, a vector A can be literally thought of as A times A hat. Like you can write it down as having two pieces that are multiplied together. And third, I'm saying in English, what that's supposed to visualize in our mind is you think of that vector A as originally having been a unit vector A that then got scaled up by the amount of raw A. Okay. Okay, this is a new way of thinking about vectors and a new way of notating them. I'm gonna, are we good? Can I move on, like hand or direct chat, or like, does that sort of seem, it's really 3 points that great. Thank you. Awesome. Delilah. Awesome. Chen. Awesome. Nadine. Sorry. Awesome. Mohammed. Awesome. Luna. Thank you. Oh, and Melanie. Awesome. Great, great, great. All right. So I'm going to move on to awesome. So what does this do for us? Oh, and Luke. Sorry. Thank you, Luke. Got it. All right. What does this do for us then? Okay. I'm going to show you this. What this says in English is then from now on, we can assign unit vectors to the three directions of a 3D coordinate system, like or a 2D coordinate, but like whatever space we're working in, each of the coordinate axes of that space, we can assign a unit vector to so that all other like arbitrary directions can be expressed relative to these three basic directions. What I mean is A hat right now is the direction of any arbitrary vector A. Like A can point in any direction. Its its direction is A hat. But just like in New York City, you can have to there's to get from John Jay to like your subway stop or your apartment, like you have to go in any random direction you want, but you always ultimately think of your navigation relative to the basic coordinate axes of uptown, downtown versus crosstown, like north, south versus east, west. Um, we can recognize in advance and assign directions not just to any arbitrary vector, but we can assign directions to the coordinate axes. So then from now on, any arbitrary vector can be divided into components pointing along those axes, like we always did in physics 203, like divide velocity vectors into a horizontal velocity component and a vertical velocity, etc. So in other words, I'm saying just like A hat by definition equals A vector over A, I'm saying now the X, Y, and Z directions, the actual coordinate axes of a coordinate system, are so important and as forming the basis with respect to which all other directions are expressed, that we could just call the x direction x hat. We could call the y direction y hat. Like we could, any x vector, we could divide by its own length and call that x hat, any y, etc. But they're so special and they are the basis with respect to which we express everything else that we give them special, and plus x, y, and z are so overused in physics as it is, partly to alleviate confusion, we say from now on, fine, the unit vector in the x direction from now on is always called I hat. And the unit vector in the y, in the purely y direction, is called j hat. And the unit vector in the purely z direction from now on is called k hat. Like, okay, so I mean, we could just call them x, y, and z. And quite frankly, some web pages or search or chat engines or whatever still will use x hat, y hat, and k hat and z hat. But if you ever see, as some of you clearly did when you did the homework, if you ever see I, j, and k with carets on them, that those are referring to the common language for the unit vector along the three coordinate axes of our three-dimensional space. Now, once you have these unit vectors, it allows you, it opens up a whole sort of language. I'm looking at the time. I'll show you what I mean. But again, stop me if. And notice my coordinate system, like you can draw a coordinate system any way you could say this is your x-axis, this is your y-axis, and that's your z-axis or something. But notice even your coordinate system should obey a right-hand rule, right? Like the whole idea of a space, everything is relative. This is all about Galileo, just expanded, 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 really. A space is a frame of reference. It's in the eye of the beholder. Like I could tilt my head and it's still that space, but it has to be an internally consistent space, right? So if I draw X coming out of the board and then curl my fingers toward Y, notice my thumb is pointing up as Z. If you don't like that, you could say X is this, you could say X is this way and Y points up, and then your thumb will point out of the board and that will be Z. You see what I'm like? What you couldn't do is say X is this way, Y is this way, and Z is the other way. There is an internal consistency once we're in three-dimensional space that keeps our positive signs all the same way. And it's the right-hand rule. Okay, so assuming this kind of coordinate system, I'm going to say if I have some random vector, let's say just in two-dimensional space for a moment, say I have some random vector A that is making an angle theta with respect to the horizontal. I might have just confused you by rotating my coordinate, but if I'm just in two dimensions for the moment, so theta is the angle between A and the horizontal reference line. I can say that A equals A times A hat. But something else I could say instead, just like from Physics 203, I can say A has some horizontal component and some vertical component, right? I can say that this is the amount, that AY is the amount that A brings us up along the x-axis, and I could say that AX is the amount that A brings us along the x-axis, right? And um, and that really means what I'm trying to say is this. I could say this. right? I'm saying the vector A, which is its length times its direction, could be expressed as a tip to tail sum, or Pythagorean sum, if you like, of component vectors, smaller vectors that lie along each coordinate axis to go from the origin up to that point right here, is equivalent to going across the x-axis a certain amount and then up the y-axis a certain amount. And that means it's equivalent to going a certain amount times the unit vector in the x direction plus a certain amount times the unit vector in the y direction, right? In other words, each of those legs, like this vector, this is a vector. AY is a vector. It's a certain amount of length up a certain direction. It's not the same vector as A, right? Like A is not the same vector as AY. What is AY? AY is a certain length, which is not the same length as A, right? Tie in a certain direction called j hat. In other words, that AY vector, the A sub Y vector, you could think of as one unit in the along the y-axis scaled up by an amount AY. There's not enough room to say that. Hold on a second. I'll go on the next page. Tell me if you need me to go back, but I'm saying in this way of thinking, like we could say that A is just A times A hat, or if we want, but then the problem is if we just say from now on that any vector is a certain direction scaled by a certain amount, that's fine. Like that works, that's correct. But then every single vector has its own unit vector, right? So A is A times A hat and B is B times B hat. So then relating the two vectors to each other becomes very difficult. They have their own sizes and their own unit directions. So in order to relate A to B, we use a common coordinate system, or what's often known in physics as a frame of reference, or even like when you get to PChem, what's known as a basis. We have A and B, they both have their own directions, but they're both in. It's just like you walk one way and your friend walks another way, but you're both in Manhattan. So you're both still in the same mindset of having to relate your navigation to an XY grid. So the XY grid is common to both of you. So each of your navigations we can divide up into components that lie along the same common basis axes, right? So we say from now on, therefore, that A is equal to some amount in the x direction times the x unit vector plus some amount in the y direction times that unit vector plus some amount z times that unit vector, right? And like by ax, what I mean is a cosine theta. And by AY, what I mean is a sine theta. Like you know that from Physics 203. I'm just trying to emphasize, I'm going to move on in a second, but I'm trying to emphasize with it seems like a lot, maybe. I don't know if it seems like a lot or not, but it maybe seems like three different ways of saying the same thing. But just notice AX, when I say that AX is a cosine theta, like you would have said in Physics 203, when I say that blue AX there on the blue horizontal vector, is A times cosine theta. I'm saying the length of it is A cosine theta. That's the length. What's the direction? The direction is I hat. Um, Wait, I'll do this even better. Hold on. I also don't know why the thing just. The big point I'm trying to make right now is a cosine theta or a sine theta. Those are numbers. Those, whatever if you're used to that from physics 203, that like the horizontal component of vector A is a cosine theta, I'm still agreeing with that. I'm still using that. But I'm just trying to emphasize now that that's just the size of that vector. The size of the x component of A is A times the cosine of the angle theta. That's the size. The vector component is a vector, ax arrow. Now, from now on, we can think of that arrow, that vector, as having two pieces, the raw magnitude, a cosine theta, and the direction, I hat. So from now on, that vector component, the ax, the vector ax, I think of as I hat, like 1 unit along the x-axis, scaled up by an amount, a cosine theta. That's what I'm saying from now on. And the other component, the same thing. Are we vaguely? It's kind of abstract. I'm going to do one last thing with that, and I'm going to throw it to you guys. I guess a warning. It's getting abstract, so now I'm going to do a couple of concrete exercises with this, and I am going to throw it to you in the chat, in the private chat. So, and I don't know why. Why did the thing change? Hold on. Okay. Okay, so here comes an exercise to see if this makes any kind of sense at all. And again, I'm going to ask you, please put answers in the direct chat. Either put an answer or a wrong answer, or put like something like, wait, can you repeat the question? Or I'm not, you put something in the direct chat, please, and then submit for points. Um, now, the truth is the answers to this, I think, were like on the front of the board yesterday, but whatever. I want you to try in the direct chat. It's not a trick. If you get it and you get where I am, once you get the answer is simple. I'm not saying it's easy, but it's simple. It's not some long answer. It's like a simple number. Well, I shouldn't even say that, but it's simple. That doesn't mean it's easy, but it's simple. And once you get it, you'll get it. But if you don't know what I'm talking about, you won't get it. So I'm asking you, it's two exercises in the direct chat. By the definition of dot product and the definition of like unit vectors, I want the dot product of the unit vector I with itself. It's always the same answer. If you like, there is an answer to this question. And then I want the dot product of the unit vector I with some other unit vector J. Okay, there is an answer. You have to know the definition of the dot product, And you have to understand that I and J and K are vectors. They have magnitude and direction. If you look back at your notes of what I just explained, you'll see what their magnitude is. Like they always have the same magnitude. So this is doable. I'm going to pause for a second. I'm looking at the time. I would like you all to try in the direct, in the quiet chat, so you don't affect each other. It's not a quiz. If anything, I'm quizzing my own teaching. Okay. But tell me, what is the dot product? Awesome. I'm seeing things in the chat already. Awesome. And there's been one person in the chat who's totally in the direct chat, totally following my instructions. I totally appreciate it. And that one person answered both the questions and did answer them correctly. I'm not trying to intimidate it, but that's awesome. Thank you, one person. I'm totally with you. And a second person in the direct chat, totally with me, totally the correct answers. I love it. I'm gonna wait for a couple more. Awesome. Oh, you saw the answer. Oh, okay. Totally honest. I love this like third thing in the direct chat is someone literally saying that they do know the answer, I guess, because they saw in the notes from yesterday. But they don't understand it. So I will explain it. Awesome. I love this feedback. It's super helpful to everybody. I'm seeing another thing in the direct chat. Oh, interesting. Okay. Now I'm seeing people, and people are looking at their notes from yesterday or whatever, which is great. Um, Yes, I agree. So I got two more answers in the direct chat. I do agree with one of the answers. I'm not sure I totally agree with the other one. Somebody might be confusing the I'm just asking the dot product right now. I'm not asking cross product yet. I'm about to, obviously, but awesome. Yes. Oh, I see something elaborate, like explaining in English. Someone's actually explaining this in English about whether the two things are in the same angle, zero, one cosine, sine. Awesome. Yes, I agree with you, person in the direct chat, and thank you for explaining your answer. Please submit for points. I see. I'm getting to know you guys much better. I will see you again in person someday. But yes, awesome, awesome, awesome. This is great. Yes. Awesome. I see so great. And I see one answer. Okay, this is a lot. Great. All right. I'm now going to say, really, I appreciate it. I know it's hard to hang in on Zoom, but you guys are totally hanging in. That's great. All right. So I'm going to say, and yes, I know I did put it on the board yesterday. Here's the deal. And then we're going to do the cross product, which is a little bit harder. And then we'll move on. Wait, what time? I'm looking at the, yeah, okay. But most of you were right. And even those of you who are not, and remember, by the way, and I don't mean to be weird, if now I'm going to tell you the right answer, if it turns out you said anything that was wrong, don't forget there's an extra portal for submitting wrong answers where you get extra points for being wrong. I'm not being sarcastic and I'm not trying to be obnoxious. And also, I'm not trying to be weird to the people who were right. But there is an extra portal for wrong answers where you get extra points because I really want to encourage you, like, to take that risk. I don't, it's just, I'll leave it at that, but please don't forget that whenever you're wrong, you get extra points for it because obviously it means you took a risk and you're with me and blah blah blah. And I'm trying to tell you, you get my point. So please don't forget that. Um, so here, if you're doing I hat dot I hat, what that means by definition from the dot product from last class is it would be the magnitude of one vector times the magnitude of the other vector, but it's the same vector in this case, times the cosine of the angle between them. Like that's the definition of the dot product, right? But first of all, but the magnitude of I hat of any unit vector at all, even if it was a hat, even if you didn't recognize the letter, but it has a hat on it, the magnitude of any unit vector by definition of this whole day is one. That is and I want to say it again. That is by definition of today, i.e., if you look back in your notes, it's definitely true. But if you didn't know that before today, you didn't know it before. They don't think I'm assuming something that you were supposed to have walked into today knowing you weren't, but now you do. So the magnitude of any unit vector, any hat, in other words, is one. Okay, so the magnitude of the other unit vector, which happens to be the same one, is also one. And then the cosine of the angle between them, well, it's the same vector, I. So it must be It's the same vector we're looking at. I don't care which way it was pointing, but it's the same vector, so it must be parallel with itself. So, so in this case, so theta is must be 0. So the cosine is 1, right? So yes, the answer is 1. And I'm saying, therefore, so that is the answer to the first question. The answer is 1. I'm saying we can conclude any unit vector dotted with itself must equal 1, right? If I did j hat dot j hat, all right, I'll just write. So I hat dotted with I hat is the same thing as j hat dotted with j hat, which is the same thing as k hat dotted with k hat. They all must equal 1. Like that, that's the case. That's okay. But now, if we go to the other, I don't know why my face is like floating everywhere, but if we go to the other thing, I mean, I do know why. If we now go to the other example, to cut straight to the chase, if we do like I hat dot j hat, and we ask, what is that? By definition, well, always that would be 1 times 1, right? Like, because the magnitude of both each of those vectors is 1 times the cosine. Well, now I and j are definitely perpendicular with each other. That's the point. They are the coordinate axes vectors, and k would be perpendicular with them as well, right? Coordinate axes are, by definition, perpendicular to one another. So now it's of 90 degrees. So now you have 1 times 0, which equals 0. So I hat dot j hat equals 0 always. And that means, in other words, two different unit vectors dotted with each other, whoops, sorry, must always equal 0. Do you follow? So that's the answer to the other question. I'm going to do a couple more now. But are we clear that, in other words, a unit vector dotted with itself is always 1? A unit vector dotted with a different unit vector, or at least a different base unit vector, must always be 0. Wait, just quick thumbs up. We're cool on that. Like that, most of you got that right in the thing, but some of you didn't. Okay, cool, cool, cool. Now, slightly more comp. Awesome, thank you guys, and please submit for points. I'm serious, and yeah, it's so funny. You, for what it's worth, you're the class I know the best at this point. I shouldn't say that, but I was totally confused when I was saying before, thinking it was a double period. The fact you're the single, anyway, whatever. I can't wait to see you again next Monday. I'll just leave it at that. And visit your lab. Okay, so what's my point? What's my point? Oh, so let's do the cross product. Now I'm going to warn you. Now, granted, this was written down also in my notes from 2 days ago, but this is you have to think about this a little bit more. We're going to do the cross product now. Remember, the cross product is supposed to yield a vector as an answer. So we're going to ask, first of all, what? Oh my God. Stop. Oh my God. Siri. No, I would not. And actually, I'm going to cut to the chase. I'm going to ask you 3 this time. One of them was not written the other day. So in the direct chat, please, I'm asking you 3 exercises now. I'm asking you cross products now, maybe slightly trickier. The answer we're looking for is a vector. So I want to know what's I cross itself, then what's I cross J, and then what is I cross K. That may seem very tricky. I don't know. It might or might not, depending how you think of things. But I'll give you one hint about the last. No, I won't. I'll just leave it. So please try those in the direct chat. I cross, it's three. I cross J, I cross K. Oh, it's all over this mug, actually. The answer is on this mug, if you can see. No, okay. It, so we're doing the direct chat. Okay. I'm seeing one thing in the direct chat. I love it. Wait. And I'm noticing already. Good. Wait. I see. Okay. I love it. Now we're talking. Okay. Okay. So there's two people in the direct chat. The first person, yes, I love the thinking, but I'm going to caution you, and you're with me. You're totally with me. All of you are that are in the direct chat. I'm going to caution you. Remember now, your answers have to be vectors. Now, I'll even now is sometimes might your answer be zero? Okay, sure. And when it's zero, technically you could say it's the zero vector. I mean, like I'm saying your answers have to have magnitude and direction. Now, if your answer is zero, then okay, the magnitude is zero and the direction is like nowhere. Fine. Technically, that's called the zero vector. And I noticed that some of you noticed that in ChatGPT or whatever from your homework, the ones that already handed it, like that's a thing. But what I'm really trying to say, and I'll shut up again, I always say that and it's never true. What I'm really trying to say is if your answer is not zero, then your answer somehow has to have a magnitude and a direction, which really means now, how can you express direction? Well, you use these unit vectors, these hats to express direction. I'm going to say this the right hand rule and all that is still true. Like I taught it for a reason. But from here on in, we actually now have a complete language for expressing sizes and directions. We no longer have to say things like out of the page into the page. Like sometimes we do, and sometimes we use the dots and the X, but like we don't have to anymore. We can always say once we know where I and J, once we know what our coordinate system is, once we have a picture that this, okay, this is the x-axis, this is the y-axis, this is the z-axis, from now on, right, once we've labeled our coordinate system in step one, DFP, then from now on, every direction is unambiguously expressed as some combinations of i's, j's, and k's. That's what I'm really trying to tell all of you. Like, so from now on, all vector, as long as the coordinate system is labeled, and again, I'm saying, like, yours might be x, y, z, mine might be x, y, z, but as long as we're both using our right hand and we label our coordinate system at the beginning of a solution to a problem, then IJK language takes care of everything. So I'm expecting to see some kind of IJK language in the answers in direct chat. I'm going to shut up and look. Okay, I'm seeing great things. Oh, okay, but I guess everything I just said relates to at least the first two people that went to the direct chat. They definitely know what's going on, but I think their answers could use some directions. Okay, and I know it's hard to type the you in direct chat too. You might literally just want to say like hat. You could type out the word hat, so I know you. Okay, you know what I'm saying. So I'm seeing things that okay. I'm seeing more. I'm seeing more directions in the direct chat. Okay, I'm seeing things in the direct chat. Awesome. I see. I see. And some people are using X's and Y's. That's cool. Okay. And I'll even, so I'm going to admit, like, this is, you are using your time well. I like to think I'm using your time well as well, but you are. And I can tell you're using your time well because I'm getting a lot of really thoughtful things in the chat that are showing that you're paying attention. But I will admit, like more of them are sort of more wrong than last time. Like this is obviously harder. Right? We like something is not totally adding up for everybody right now. So we are not wasting our time. I don't know why I feel like I have to say that, but like we're here together on Zoom for a reason, and I appreciate it because there's something that's not perfectly clear to some of you. So I will clarify it in a moment. Like in other words, I'll say I am seeing many answers that have like sine theta in the answer. Well, that's awesome. You could not write sine theta without having been paying attention for the last 2 days. Clearly, you are correct. I mean, you are correctly following something because the cross product does incorporate sine theta. I'm telling you now that this concrete example I'm giving you, this concrete exercise, like I think you know what the theta is. Like I think you could take it further. I think you can actually get an answer for me because I think you can figure out what the theta is in the same way that we did 2 minutes ago with the dot product. Just saying. Okay, so I'll shut up and say, now we're talking. I'm seeing answers now that are improving. Cool. Uh, ooh, definitely improving. Awesome. I love it. All right, I will weigh in a second, but some people have given more. And by the way, I don't even know how to do this in the portal. I should start. I'll make a new portal or something. If you like put in an answer and then you revised it and put in another answer based on what I just said, like, screenshot them both and put it in the portal or something. Like, I want to commend you for that. Like that, talk about like, hanging in there. That's great. And I'll see if I can give you double points or whatever. And if you put question marks in indicating that you're starting to lose the plot, fine. I will wait. No, that's not what the question marks mean. Wait, no, it means they're questioning their own answer. Okay. Okay, so clearly we need some answers here, but this is great. Like I feel like this is a class. Wait, okay. Okay, wait. I'm just looking, and part of me wants to. I almost want to just respond to each one privately, but I that won't be efficient right now. I'm going to give you the answers. I'm going to say one more thing. I'm glad that you're getting this concept of out of the page into the page. That is definitely a concept, out of the page into the page. But I also want to say again, like once I've specified I, J, and K, once I'm either literally once the question is already phrasing in terms of I, J, and K, or if I had a drawing on the page which showed you where X is, where Y is, and where Z is. Once I have a picture that shows you what is in and out of the page and what is on the page or whatever, then we don't have to say those words anymore. I'm not saying you can't, but well, you'll see in my answers in a minute. Like there's a couple answers in the chat where people are referring to in and out of the page. Again, that shows they're totally paying attention. But like actually, since I phrased the question with I's and J's and K's, I don't even know which one is out of the page or in the page. I'm just saying so you can just stay in the IJK language once anyway. So here's the answers. Wait. Oh, okay. I could tell that someone totally just heard what I totally just said, which is great. Great. Okay. Oh, yes. I'm just gonna leave the very last person who just caught yes. Awesome. All right. So here you go. That's great. So here we go. And this is always, right? Like I didn't even provide you. Once we know that if I always means the X hat vector, and J always means Y and K always means Z. And it does. Like that's not arbitrary. It's a convention, but it's universal convention. So then I cross I necessarily equals the magnitude of I, right, times the magnitude of I again, times the sine of the angle between I and I, right? So that means 1 times the sine of the angle between a vector and its own self. The vector is definitely parallel to itself, so it's the sine of 0, right, which is 0. So this is so I cross itself technically is the 0 vector, is 0. Backing up, remember, cross product always measures how perpendicular two vectors are, how much they are differing in direction. Well, a vector does not differ in direction at all with itself. It's parallel to itself. So the cross product of any vector with itself is zero. The dot product is one. I mean, if it's a unit vector, but the cross product is zero. And I think most of you actually got that right. But now if we go to I cross J, okay. Well, that will be, I'll skip to the chase. That's 1 times 1 again, like the magnitude of every single unit vector is 1 times the sine of the angle between them. Well, okay, the sine of the angle between I and J. Well, between I and J, those are the unit vectors for the specific coordinate axes, right? That's why they're given these special letters, I, J, and K. They're not just any unit vectors. They're unit vectors for the coordinate axes, and the coordinate axes are definitely perpendicular to one another. So the angle between coordinate base vectors, so to speak, is definitely 90 degrees, right? And the sine of 90 is 1. So this, sorry, that's what I should be saying. So the magnitude of the cross product, between I and J hat is 1. But now here's the tricky part, or the part that tricked up some of you at the beginning. That's the magnitude. But if we're doing cross product, we have to get a vector as an answer. Our answer has size, but it also has direction. Well, I don't know. How do I know the direction of this answer? Well, I know because of right-hand rule. I know that the direction of the answer has to point perpendicularly to the original two vectors. If I place my right hand, the fingers of my right hand along one vector, I don't, whatever vector I, and I curl them toward the vector J, then my thumb points along the last remaining coordinate axis. That is, by definition, K. Like, in other words, the direction of the answer is K hat, and the magnitude of the answer is 1. Like, the direction of the answer is K hat. That's like the purpose of these hat vectors, is allowing us to say direction in and of itself. So the answer to the full thing, I'm running out of space, but I'm saying technically the answer to our question is 1 times K hat, but 1 times K hat is K hat. So if you cross, and this, yes, this is what was written on the board like 2 days ago, or last minute. I'm saying if you cross I with J hat, you get K hat by definition of like all of this stuff. Right? You don't get 1. You get a vector whose size is 1 and whose direction is perpendicular to the x-axis and the y-axis, i.e. points along the z-axis. So you get K hat. That is, and if you follow what I'm saying, then thus always, like always, I'm saying I cross J will always equal K. And similarly, to cut to the chase, then J cross K will always equal I. Like if you just rotate your right hand, the whole hand rotates. That's what we're saying here. So J cross K would wrap around and give you I. But what I asked for the final question of the exercise, as I'm looking at the time, we have said, okay, what I asked is, what about, what did I ask? I think I asked I cross K. Well, hold on. I'll just finish the thought. If you agree with me so far that I cross J equals K hat, J cross K hat equals I hat, and similarly, K hat cross I hat will equal J hat, right? It just, right? Then what I asked, what is I hat cross K hat? Well, that how am I going to break my? I don't understand how to do that, Yaverbaum. Like, what am I supposed to like put my fingers on my thumb now? Like, what are you even talking about? I don't know either, except I do know this. And some of you did get this right in the chat, but this is the trickiest one. I hat cross K hat, I don't know, but I know this. It must equal the opposite of K cross I, right? Because the right-hand rule is anti-commutative. So I cross K must be whatever the reverse of K cross I is. And K cross I just wrote there is J. So to finish this, so I cross K must equal negative J. And so on with all the others. I don't know why that just got lighter. I'm going to pause for a sec. I'm saying I cross K is negative J, like the opposite of J. Similarly, K cross J would be negative I. I'm going to pause on that. We have 4 minutes. And there is one more quick thing I want to do. But are you clear on that? Like like, do you see how that works? Like hands, not hands, or thank you, Delilah. Thank you, Michelle. Okay, awesome. Thank you, Luder. Awesome. Then, with 4 minutes left, I'm going to give you one more. I'm going to drop one more bomb on you. Now, it's not okay. With all of this, and why is that keep? We started this whole discussion with the dot product and the cross product. I'm now going to write them a final way. Sorry. In 3 dimensions. We're in 3 dimensions now. If you have two random vectors, which can from now on be expressed this way, and they will be expressed this way from now on, like each vector is the sum of its constituent component parts. Then the dot product of two vectors is if you want to write out the dot product of two vectors this way, if you think of vectors from now on as sums of component vectors, if you dot two vectors in 3 dimensional space, you would FOIL out all the terms, right? Like I should have written it. Like to do the dot product of A dot B, you would literally do AXI hat dot BXI hat plus AXI hat dot BYJ hat plus, like you'd have 9 terms, right? If you were doing the dot product of two vectors out, you'd have 9 terms. That looks like a total mess. And each one of those terms would be an individual little dot product. But all of the cross dot terms would cancel, right? All of these would all cancel to 0. And all of these similar terms would all be 1. So the dot product between two vectors at the end of the day, this we're going to end right now. I'm not going to do the cross product today. I'm just going to end right here. I'll write on the next page. Therefore, the dot product between two three-dimensional vectors from now on can be viewed this way. This is equivalent to AB cos theta, but this is a way of understanding if you don't know what theta is, if you're just given two vectors in an arbitrary XYZ space. Why did that just? Okay. If you don't know what theta is, it's 1040. The dot product of two vectors can be seen as the sum of the products of their matching components. The x component of one times the x component of it. And these are all just numbers. Those are numbers, right? The product of their x component lengths plus the product of their y component lengths plus the product of their z component lengths. That's what the dot product is. It is how much they match, how aligned they are. That is equivalent to AB cos theta, but in a totally different notation and a totally different way of looking at it. And that's 10 for. Okay, you've been very patient. You've been great class. Please submit for points. I will see you in 2 days. Stay warm, stay dry, stay dry, stay warm. But I'm here for, well, I'm here for questions. Yeah, bye. I have another class coming in, so I can answer a question. Okay, have a good day. Yes, have a great day. Thank you. Awesome. And have a good day. Question mark, he says. Okay. Uh, okay, great. Thank you, guys. Thank you. Thank you. Awesome. And Ali, wait, I'm turning off the recording.